Welcome to this EPLAN video where we will be showcasing the creation of a system from pre-planning with a graphical machine or system layout through the detail engineering, creating the control drawings, the schematics, and also creating the 3D cabinet from there and laying out all of the hardware requirements for our I/O. First off, using pre-planning, I can create a pre-planning page, and this is going to be my graphical machine layout. In this page, I'm going to insert graphical views of my system, and behind each one of those graphical macros, we have also control components that are captured in the background. However, the user doesn't need to identify individual control components. He just identifies the graphical elements that he needs for his system. In this case, we've got two conveyor systems and two grinder systems. This is our pre-planning navigator, identifying the various different functions. And behind each one of those functions, you can see that the system created the required control equipment, in this case, the drives as actuators. Each one of these objects in pre-planning can carry a lot of data. First off, it carries a designation, it can carry a description, and also data concerning the planning. So if you needed to generate a quote, the system could capture here all of the quoting information, such as how long does it take to plan, how long does it take to build, how long does it take to program, what are the costs involved, and also maybe what is the power consumption for that particular device. In addition to that, the system can also define what type of I/O requirements are needed for that particular actuator. In this case, we need 4 inputs, 3 outputs of digital nature. The symbolic address or tag can be generated automatically from pre-planning using the tree and the structure associated with these objects. And finally, the function text can also be specified or modified if needed here in the pre-planning environment. Additionally to the PLC, we also have a macro. A macro is a circuit or a section of a circuit that represents the controls for that particular equipment. In this case, we've got a drive schematics consisting of 3 pages with the power for the motor, the inputs, and the outputs. Additionally to that macro, we can also specify placeholders which identify the size. In this case, I can choose between 2 motors, motor A and B, one at 1.5 kilowatt and one at 0.5 kilowatt. And based on the selection of the motor, you can see that it also adjusts the size of the wires, the size of the cable, the size of the protection devices needed for that particular circuit. All of this can be captured directly in my pre-planning environment, and the information is then stored without even having created a single page of schematics. Now I need an overview of what exactly is this machine going to cost, and also the planning data that I captured in this tree. For that, we can simply generate a report. This report is going to be a planning object overview, and it's going to summarize all of the information contained in my pre-planning or in my graphical pre-planning. Here's the result. It's a report identifying all of the objects in my system, my 4 drives, identifying the I/O requirement for those drives, and summarizing them also at the end. So I know exactly what quantities of I/O will I need for that particular system. All of my values for planning, construction, and software were also captured in this report and summarized at the end, so I have a complete idea of how long it's going to take to put this system together, as well as summing up the price. So we could use pre-planning as a quoting tool right up front in the engineering process. Now I would like to create my schematics. So I can take individual objects from the pre-planning tree and simply via drag and drop place the macros that were associated with them in the pre-planning navigator. So I can do that either for one particular function or I can do that for all of them. So if I select all three of these drives, I can create the rest of them also by drag and drop into my page navigator. So using the data from the pre-planning, the system creates my pages and also all of the information associated with them. Now that I created these detailed schematics, I can go ahead and assign the PLC hardware information. So if I go to my PLC environment, you can see here these are the cards that were created generically by simply dragging and dropping those macros into my drawing. However, I would like to import a configuration from a PLC manufacturer. In this case, let's use Rockwell Studio 5000. If I go to Studio 5000, I have the layout here for a rack containing a power supply, chassis, I got the controller, I've got an IB16, and I've got an OB16i. So that should be sufficient for this particular system. I'm going to export and create this AML file. AML, which is Automation ML. I can simply now import this file into my PLC environment. So I'm going to import this Automation ML file. And now you can see it created additional cards, and one of these cards is the input card. So I'm going to simply filter my digital inputs, and these are the digital inputs that are in my project. So I've got 16 of them. So I'm going to highlight them. I'm going to simply say PLC use connection point blockwise, and now I'm able to map the I/O information from the schematics to the I/O information that was imported from the AML file. So here are my I/Os. So I select all of the digital inputs that I need to map, and you can see here now it maps. So the initial connection point designation was 16 by simply creating the macros, but now by associating it to the card, it actually transfers it to 4. So now I've got an association between the I/O in the schematics and the I/O in the hardware definition. I will do the same for my digital outputs. So here I've got 12, highlight them, do the same thing, PLC use connection point blockwise. This time I will select my output card. So I can select all of the outputs. Of course, we can use a filter if we want to, but in this case, the system is not that big, so I can simply quickly select them. Okay, and now I've associated those particular outputs to my hardware. And now if I were to create a PLC overview page, I could just simply drag and drop these two cards and visualize the complete configuration of my I/O. So here's the input card. All of the I/Os have been mapped, and I can create a new page, and I'm going to drag and drop my output card in here. And here we'll have an overview over all of the output points. Now I'd like to create my panel layout. So for the panel layout, why do it in 2D when it's quicker and easier to do it in 3D? So for that, we're going to look at a layout space, which is my 3D environment. I'm going to insert an enclosure. For example, a 600 by 760 AE cabinet from Rittal. Then I'm going to isolate the mounting panel so I can lay it out. We're going to change the view, and I'm going to insert some wire duct. So let's go from top to bottom, from here to here, and from here to here, and in the middle we'll do another one. Here to here. Then I'd like to lay out some DIN rail. Select the part number, will identify the size and the dimensions of the DIN rail. I'm going to right click and adopt the length of this particular duct. Then I'm going to place it centered between these two, and same thing here. I'm going to adopt the length of this duct, and I'm going to place it centered between these two. So now I can locate all of my 3D equipment or my equipment for my cabinet, and I can start dropping in, for example, let's start with the protection devices, place them here. 1, 2, and 3. And for this one here, we'll have another one, 4. So I've got 4 devices. So I can snap them easily to each other. Then I'm going to place my contactors. So if I drag and drop, I'm going to place them right here on this DIN rail. And finally, I'm going to place my terminal strip with all of my terminals. And this I can just simply place it up here where I've got space. So X1, I can do X2. Oh, I probably don't have any part numbers associated with these. I do. There you go. And now, if I wanted to, I could even highlight the whole thing and do my wire routing. And there you have it, a complete cabinet laid out, routed, ready to be built. So, again, to summarize the workflow, we started with a simple machine layout, identifying the requirements for my system. From there, we identified or summarized the quote information. Then we created our schematics. We laid out our I/O, and we laid out our cabinet in 3D to manufacture and build that particular enclosure. Thanks for watching. Hope you've enjoyed it, and check it out as soon as you can.